Okay, so in this video, I want to show you how you can get involved in the PhysLean project. So as the screen says, PhysLean is a project to digitalize physics into the lean theorem prover. For this talk, I'm kind of gonna assume that you know what lean is. So I'm not really going to go into those details. What I'm really interested in is if you're interested in getting involved but don't know where to start and don't know what to do, this video is for you. So if you go to the PhysLean website, which is just physlean.com, and you go on the Get Involved and you go into the Get Involved tab, there are a number of ways that you can get involved. The easiest way is to promote the project, to let people know about it. If you know some physicists that might be interested in contributing, if you know some people that write lean code or are interested in this sort of project more generally, letting them know, promoting this in any way that you can. You can come and discuss PhysLean on the Lean Sulip. There is a channel specifically dedicated to PhysLean where you can ask questions about the projects. If you really just don't know where to start, just say, look, I don't know where to start. What can I do? Happy to direct you there. And there are some ideas of projects there, which we'll get onto in a second. You can read through some curated notes and let us know what you think. Let us know if you can understand them. Let us know if there are typos, mistakes, or errors. So if I go into what a curated note is, let's go into the quantum harmonic oscillator. A curated note is, for example, it's basically a note created from the lean code, but it's slightly more curated than the lean fast itself. So it's not every definition and every lemma in lean. It's rather a selection of those that hopefully tell you the story of a formalization. It's more like that, more similar to what you'd see in a physics paper than a very detailed maths paper. So this is for the quantum harmonic oscillator. You could, for example, read this. Let us know, does it make sense if you don't know lean? What could be improved? Some of the definitions might not be the best. And if you want to make a suggestion about a specific definition and lemma, you can use this drop-down box here, and it will create a GitHub issue for you. If you also want to create one of these notes, please do. There are topics within PhysLean that don't have curated notes, and I think curated notes are a good way to allow people to access PhysLean without necessarily knowing lean. You can help with issues, so like any GitHub project, there are a list of issues. These range from things like documentation to infrastructure to formalization. So any help with any of these issues, perhaps if you're more from a software side and you really know how to use GitHub and know how to do the infrastructure and all of that sort of stuff, any help in this direction would be great. There is a to-do list. And so these are a list of items from the lean files. So if you click on one, you should get taken to a lean file. And they're basically a list of things that we need doing or that we want doing. And you can, if you want something doing, put a to-do item in there as well. Some of these are probably not the best well explained. Most of them I have written, and I'm not the best writer in the world. So if you're looking at one of them and they don't make sense, but you kind of have an idea, you just want to make sure, just ask. I'm happy to explain in more detail, what these two items are for. Any help like golfing the code, making the code shorter, making the code more nice, adding comments to the code. If you're from a physics background, perhaps explaining a definition, adding more explanation, adding examples, all of that sort of stuff is very helpful. Basic, structure of the code. PhysLean, hopefully, it's going to be a long-term thing, and to make it a long-term thing, we have to make sure the code base is nice and it works well and it's well documented. So this brings me on to informal results. In PhysLean, there are things called informal results. So most of the results in PhysLean are formal definitions and lemmas. So they have been written in Lean, and Lean has checked them for correctness. To kind of mitigate the fact that it's a lot easier to write things in English than it is to write stuff in Lean, Lean has these things called PhysLean rather has these things called informal results or informal definitions dilemmas. And this is a graph that shows you all of them. So you can click on one and it will tell you down here, let me move myself, and it'll tell you down here, what this definition, what this informal result is, and you click on this and it will take you to that place. So you can come and you can try and formalize these informal results, basically make them, write them into Lean rather than write them into English. And you can also help write these informal results. So perhaps you don't know anything about Lean, but you know a lot about physics. You can write these informal results in English. The aim would be to make them fairly small steps rather than just putting, like a big theorem. You break that theorem down, and then someone can come along that perhaps doesn't know physics and formalize those results. So that's an easy way to get involved if you don't really want to get hands deep into Lean. There are projects, well, there's one project, which is about quantum mechanics on the GitHub. And this is to basically formalize properties of quantum mechanics. So there's a bunch of stuff that I've done related to the quantum harmonic oscillator, but there's a bunch of other stuff. And you can come over here and you can click, for example, the reflectionless potential, and there's a bunch of things that we need to be done, or that we want to be done with respect to the reflectionless potential. Feel free to add to these projects. Feel free to make your own project. Perhaps you can help structure a project like this for electromagnetism or fluids or electric dynamics or hydrodynamics or quantum mechanics or quantum field theory, etc. Making such a project is always of a great help. Let's go back to the page. And then there are these mini projects. I'm gonna have to move this a second. There are these mini projects on the Lean Tulip, or on the PhysLean channel of the Lean Tulip, which are basically small projects which you can get involved with. For example, the 2-Higgs doublet model, grand unified theories, properties of the Pauli matrices. So that's another source of ideas. If you want a slightly more long form thing that might take a couple of months, this is the place to look. But yeah, so that should hopefully give you an idea of how you can get involved in PhysLean. The easiest way really is just contact me or contact people involved in the project. Just ask, I want to do this. Can I do this? Or this is my background. What can I do to help? Always happy to answer. So I'm going to end this video here. Let me know if you have any questions, and thank you for watching.